Hey everyone, hope you're doing well. Here's a video to go along with yesterday's lesson. Sorry I'm getting a little bit late to put this out. Mondays will probably be a little bit late, but Wednesdays I should be able to get them up on the same day. So, what we did was I introduced the next assignment called Functions and Libraries. You can see right here. And so for this assignment, you're going to be creating a file called My Tools, and your code will only contain functions and will not run any code when the program is run. All of the functions should be well documented and explain how that function should be used, what the parameters are, what type they should be, what the function does, what the function returns, etc. So, good documentation so that everyone who uses your tools will know exactly how to use them. And so for this, you're going to be making three functions, though one of the functions is actually two functions. So the first one is create a function called getNumber that will get a integer or a floating point number from the user and make sure that sure, so get an integer and a floating point from the user, error check it, and give the optional parameters for having a minimum or maximum for range checking. So you can see down here, it's going to have four different parameters: the minimum, the maximum, the type, and the message. The message will be what is the message that we are displaying to the user when we're getting a number. And it will return either integer or floating point number. And so probably the easiest way to do that is you can actually assign the casting functions to their own variable. And so that allows you to do something like this. Say we set the mode equal to int. Then I don't have to use int in order to convert it into an integer. I can use my mode variable. For example, mode 2.5. It turns it into an integer for me. I can do mode string 7, and it turns into a 7 for me. Or if I wanted the mode to be a floating point, I can set it to a floating point, and then mode 3.14, and there we go. It turns it into a decimal for me. So that is probably the easiest way to handle the mode and conversion between an integer or a floating point number. The next one is a function called makeChange that will take in one parameter, a decimal number representing some amount of money, and it will return how much of each bill and coin are needed to equal that amount as a string. So, and then after that, you're going to be creating a function called getChange that takes in two parameters, how much a person owes and how much a person is paid in cash, and return what the bill and coins are that they receive and return it as a string. So basically the same thing as the makeChange function, except for it takes in two parameters and then has to calculate the amount given as a change rather than giving the amount directly. So to do this, you should call the makeChange function to calculate what change should be given. Do not copy and paste the same code into getChange because it's going to do almost the same thing. It just has to calculate how much change needs to be made first before it calls makeChange to actually get that string. So the hint for this function is to use integer division and the modulo functions to calculate how much of each denomination should be given as change. This is what you're going to want to use for the makeChange function. And how those two work is they're kind of like division that we learned in elementary. So say I got a number like 17, and if I normally divide it by 5, well, I get 3.4. But I can do integer division, which is like this, and it'll just give me 3. So it gives me the whole number of times that 5 goes into 17. 5 goes into 17 3 times. And what is the remainder after you divide 17 by 5? Well, that is what the modulo function does. It gives you the remainder. And so between the two of them, you can use them to calculate change. what you do, you start off with the largest denomination. In this case, it would be $100 bills. And you say, okay, if I want to make change for, say, 250 bucks, I say, okay, how many hundreds should I give them? Well, I should give them two $100 bills. Say, okay, after I give them the $200 bills, how much do I still have to make change for? Well, I have to make change for $50 more. And so then I would use that remainder in order to calculate the next denomination. All right, so that is how you would calculate change, is by finding out how many times that bill goes into how much you need to make change for, then find the remainder to see how much change you still have to make change for. Make sure you go from largest to smallest, because if you go the other way around, then you're just going to give them a whole bunch of pennies. That's it. All right, so that is the second function. And the third function is called isPrime. That will take in an integer number as a parameter and return true if that number is a prime number and false if it is not. Note that there are several opportunities to improve the performance of this function so it runs faster. Without optimization, this function will be very slow when applied to large numbers. So, you can do whatever you want with this. Use your math knowledge and understanding of primes in order to calculate whether or not it's a prime or not. But yeah. So those are the three different functions you're going to be making for this assignment. This assignment does not have any testing software. And the reason is because I want to take a look at your code and make sure that you have good quality code. It's possible to make code that works, but is not very good, hard to read, or it'll be difficult to maintain. And so that's what these kind of assignments are for, is to help you improve the quality of the code that you're writing. Also, these assignments, you do not have a limit of how many times you can submit them. So you can submit them as many times as you want. I will always mark them and give you the higher grade, and so you can keep on making corrections until you get the mark that you want. So that is how these larger assignments will always work. That's almost everything that I wanted to show you. I do want to show you why you might want to make these sort of libraries. So over back at our guessing game function program that we made a bunch of functions. So a lot of these functions would be useful for other things. Like if I made another game, I might want to still use this play again function. And getNumber is a super useful function. You can use this getNumber function as a template for the getNumber function in the assignment I just showed you, but it doesn't contain everything that it required. So you can use this as a start, but you're going to need to add to it. But what if I wanted to access these functions from a different program? Well, you can. So I'm going to save this as just a guessing game, I guess, because I want to give it a good name. Guessing game. Actually, I need to give it no space. So, guessing game, I guess I would call it guessing game 2. Sure. That works. So now, I'm going to go to a different file. Just make a new program. And what I'm going to do is I'm going to access that guessing game program by importing it. So I'm going to import guessing game 2. Pretty sure that's how I spelled it. Got to make sure that your spelling is correct, right? Guessing game 2, good. And so what this is going to do is it's going to load that entire program and allow me to access the functions that are inside of it inside of here. So I can say just call the getNumber function, and it would access it for me. However, I do need to say where to get the getNumber function. So I need to say guessing game 2 dot get number. And this is exactly the same sort of way that we did the random, right? So when we imported random, and then we wanted to use it, we said from the random library, we wanted the rand int function. Like that, right? So same structure. You got what are you accessing it from, and then a period, and then what function are you trying to get. And this needs to have two arguments. Let's say, remember it needed to have an upper limit and a message. So we'll do that. But if I run this thing, it's not just going to do this. It's actually going to run the entire game. We'll see that right now. So we're running it. It didn't have any lines, but look, my game is for some reason running. Why is that? There we go. So it's playing my game, and then it actually did do my message down here. So the reason why it's doing that is because whenever you import a file, it actually runs everything in that file. So what we can do, and something you might have seen in other Python programs, is something like this. I'm going to take everything that is in our main code, I'm going to tab it over, like that, and I'm going to say, put an if statement right here. I'm going to say if double underscore name equals double underscore main. Just like that. And what this does is it stops any of this code from running unless if this file is run directly. So when I imported it, I did not run it directly. I was running that particular file that we made here, right? So this was a file that got run directly. And whenever you run a file, every time you run a program, it always has a name. Typically, the name goes along with what the file name is. But when it's run directly, the name is called main. And so that's what it's doing. It's checking whether or not we're running this directly. And if it is, it's going to run the game. But if it's not run directly, then it's not really going to do anything except for initialize all of these functions. So now, if we save this and go back to our other program, and let's put in a better message here, enter a number. There we go. And if we run this thing, say num equals this, and then we'll just echo it back. Print num. We'll see that we do get the get number function running, and it echoes it back to us. And this is exactly what I was doing with the testing program. So this unit test that you guys were using for the functions exercise, that is what this is doing. It's importing your file. I'm doing it in a little bit of a weird way. So when I write it like this, from the file import and then start a wildcard, which is saying import everything, what that does is it means that I don't have to write the name at the beginning. So I can change this. So I can say from guessing game 2, import everything, and now I don't need to give the name. I could do the same thing here as well. I could say from random, let's just import, not necessarily everything, but I can define what it is I want to import. I can say I want to import rand in. And now I don't have to have that either. I can just say, call the rand in function. So just run this, show you guys that it works. And there we go. So that is what, when you do the import using from, it just means that you don't have to define or tell it what file you're getting that function from. So that is that. It's a nice thing to have because it allows you to reuse code that you've written for other projects and still access them from a different file, or to have a single file or a single program that's spread out across many files, which is very common when you are working with other people. Last thing I wanted to show you guys, a bit of a advanced concept, but since we're kind of looking at functions, we may as well look at the last sort of function that exists. It's called a lambda function. And what lambda functions are is they're basically minor and usually temporary functions that you use for small things. The nice thing about them is you can write them in a single line. The other nice thing about them is that you can create a real function that returns lambda functions. So a function that creates functions. Kind of weird. And how it works is like this. You can assign it to a variable. So I'm going to assign this function to the variable x. And I say lambda, with an A, lambda, just like that. So you change its color. And then I give it two things. The first is basically what I would call the parameters of the lambda function. So it's going to take in one parameter, and then what is going to return, and this is going to return f string. The number is I, just like that. And now I have a lambda function. And so if I say, okay, print x, and I give it 6, so 6 is going to be the value that I takes on, and it's going to return this string, and so it's going to print the number is 6. Just like that. I could do the same thing with some other, like that. And so this is a nice and easy way to make simple functions without having to go and define them. They do have some purposes. Sometimes you give them the lambda function as a parameter to another function. So you can get into some pretty complicated stuff with this. I'm not expecting you guys to ever use these things, but they might be a solution to a problem that you run into in the future. I just want you guys to at least be familiar with that these things exist. So lambda functions are common in all programming languages, but the way that they're handled can be a little bit different. For example, in Java, lambda functions cannot be assigned to a variable. They are strictly temporary, only used once. So that is a lambda function. We talked about the assignment. We took a look at importing and exporting, importing other programs so they can access the functions that are inside of them. And we also saw that you can assign the casting functions to their own variable so that you can use the same variable to do two different types of casting depending on what you set it to. So that is everything that I think I wanted to cover today. Next time, we will get started with arrays. So looking at lists and how do we access strings, indexing, that kind of thing. After that, we will take a look at the other kinds of arrays, like dictionaries and sets and tuples. But yeah, so due date for this will be next Monday. So you have a week for this new assignment. If you have any questions, feel free to email me. Otherwise, I will see you all on Wednesday. Have a good one.